Significant changes were made to the B-52G design. Additional fuel tanks were added to the wings, more powerful jet engines, as used in earlier models, were installed, the vertical tail was reduced, and a remotely controlled tail turret was fitted. The aircraft also received improved navigation and targeting equipment and an electronic warfare system. The first flight of the prototype took place in October 1958, and in February of 1959, this model began to be delivered to Strategic Air Command of the United States Air Force. Overall, from 1952 to 1963, 744 Stratofortress aircraft of various modifications were built. Among them were 193 B-52G and 102 B-52H, the first truly intercontinental versions that were specifically created as carriers of missile weapons. In the early 1960s, the B-52H aircraft were planned to be equipped with the Skybolt aeroballistic missiles, but that program was canceled in 1961. In 1972, B-52G and B-52H aircraft began to be equipped with aeroballistic missiles produced by Boeing, which had nuclear warheads with a yield of 100 kilotons and could strike fixed targets with known coordinates at ranges of up to 100 miles. Each aircraft could carry 8 such missiles in the bomb bay, plus another 12 missiles under the wings. These missiles were intended to clear enemy air defense systems so that the bombers could reach the target. A number of aircraft were converted into trainer variants for crew training on the ground. One of the bombers was modified to serve as a carrier for the experimental North American X-15 hypersonic aircraft. The first separation from the carrier took place on the 8th of June, 1959. From 1971 to 1977, all B-52G and B-52H aircraft were fitted with an electro-optical reconnaissance system, which significantly increased the aircraft's combat capabilities at night and protected pilots from being blinded by a nuclear blast. Since 1985, part of the B-52G fleet began to be equipped with receivers for the Navstar satellite navigation system. From 1981 to 1990, all B-52G and B-52H aircraft underwent modernization of their offensive electronic warfare systems. In the early 1970s, instead of the old missiles used as means for suppression of surface-to-air missile complexes, new missiles were adopted, and in the early 1980s, cruise missiles entered service, which greatly improved the ability to strike without entering enemy air defense zones. However, this method of attack became standard only in the 1990s, when Rockwell B-1B strategic bombers reached combat readiness. In the 1980s, a typical mission envisaged using cruise missiles to suppress enemy air defenses, followed by a penetration to deliver a nuclear strike with conventional bombs or rockets. From 1984 to 1991, 195 bombers, 99 B-52G and 96 B-52H were modernized to carry 12 Boeing cruise missiles with nuclear warheads, 6 on each underwing pylon. From 1988 to 1993-96, B-52H aircraft received an additional 8 such missiles on a universal multi-position launcher inside the fuselage. Thus, one B-52H could carry up to 20 cruise missiles. At the end of the 1980s, the armament was supplemented with cruise missiles with non-nuclear warheads. The B-52H was also armed with low-observable strategic cruise missiles, 4 missiles on a multi-position launcher in the fuselage and another 12 on external hardpoints. At the end of the 1980s, 69 older model B-52 aircraft that had not been upgraded for the new strategic cruise missiles were reassigned to other tasks. They were to deliver conventional non-nuclear weapons. In 1988-7, such bombers were equipped with Harpoon anti-ship missiles, up to 12 on each aircraft. They could also be armed with mines or with Raptor precision missiles of Israeli manufacture for strikes against ground targets. The largest number of B-52s in service was in the early 1960s, more than 600 bombers at the same time. From 1965 to 1984, older variants were gradually retired. By the beginning of 1992, the U.S. Air Force retained 254 B-52 aircraft, of which 33 were permanently reconfigured for conventional missions with conventional bombs and Harpoon anti-ship missiles. On March 3, 1992, a historic event took place. 2 B-52 bombers took off from a U.S. airbase in Louisiana and headed for Russia. After 12 hours, having crossed the Atlantic Ocean and refueled in the air over England, they found themselves in the heart of Russia, over Ryazan. Thus, 40 years after its creation, the strategic bomber B-52 for the first time made a flight to Russia, for which it had once been built. But this time the aircraft carried no weapons. It was a friendly visit to Dyagilevo Air Base, where the 50th anniversary of Russian long-range aviation was being celebrated. In August of 1993, the destruction of 350 B-52 aircraft began at an airbase in Arizona, in accordance with the Strategic Arms Reduction Treaty previously signed with the Soviet Union. A special machine cut each aircraft into 5 pieces. By 1994, only 130 B-52 aircraft remained in the regular Air Force. In 1994, by agreement between America and Russia, it was decided to retire all aircraft of the older variant. It was decided to keep only 85 bombers of the newer B-52 version. Another 20 such aircraft were kept in reserve until the middle of 1996, and 9 were transferred to the National Guard. The U.S. Air Force is carrying out a large-scale modernization of the B-52 bombers, primarily to improve their capabilities as carriers of non-nuclear weapons. Although these aircraft are already over 33 years old, 102 B-52s entered service in 1961 and 1962. Air Force leadership considers it appropriate to keep them on duty for a long time. The service life of each aircraft is planned to be extended to the period from 2030 to 2040, with an average flight time of about 395 hours per year. 47 B-52 bombers were modernized under the program to enhance non-nuclear strike capabilities. Here is what was changed. On 18 aircraft, the cargo bay was reconfigured so that Harpoon anti-ship missiles could be carried. 10 aircraft were armed with tactical Raptor cruise missiles for strikes against ground targets. The conventional weapons release control system was connected to a modern digital data bus, which allows the use not only of the aforementioned missiles, but also prospective next-generation precision weapon systems. Cruise missiles, guided bombs, and munitions with trajectory correction that take wind into account. The system enables a rapid transition from nuclear weapons to conventional ordnance. Cockpit lighting was adapted for crew operations with night vision goggles. Based on the experience of using the B-52 in Operation Desert Storm, the electronic warfare suite was strengthened with a third set of electronic countermeasure systems. The additional equipment was installed in the tail section of the fuselage in place of the gun turret, which was removed. All aircraft are equipped with a GPS satellite navigation receiver that works together with an inertial navigation system. The inertial system is duplicated. This was done in case of a nuclear war when GPS operation might be disrupted. In that case, the aircraft would be able to perform a combat flight using only inertial navigation. The old Honeywell inertial navigation system was replaced with a new system using laser gyroscopes. The forward-looking infrared system and the television night vision system were also replaced with new equipment of similar purpose. Another 18 modifications are aimed at improving the reliability of onboard systems and enhancing the aircraft's operational characteristics. To increase the accuracy of delivering conventional munitions with regular combat loads and to reduce operating costs, the B-52H upgrade program provides for the replacement of the old inertial system with an improved system using laser gyroscopes. At present, the maintenance and operating cost of the old system, which used electrostatically suspended gyroscopes, is considered too high. The inertial system upgrade for the B-52H is being carried out not only so that the bombers can employ high-precision weapons with conventional warheads in local conflicts, but also to enable these aircraft to be used in the event of a large-scale nuclear war. For this purpose, the onboard satellite navigation receiver is tied into the inertial system. This should allow the aircraft to continue the mission using inertial navigation alone if, during a nuclear conflict, the satellite system becomes disrupted. To improve night operational capability, the upgrade program modernizes the electro-optical targeting and observation system. The forward-looking infrared system and the low-light television observation system are being replaced with new generation equipment serving the same purposes. In addition, individual night vision devices for pilots are planned to be added to the aircraft's onboard equipment suite. This required a radical change to the lighting scheme for cockpit illumination and crew alerts about onboard systems and external threats such as radar illumination and missile launches. The current red lamps and orange-red light panels cause prolonged afterimages on night vision goggles. so they are being replaced with blue-green information panels according to the scheme that has been in use since 1996 on F-14B carrier-based fighters. Besides the major modifications listed above, smaller changes under the upgrade program are aimed at improving the aircraft's operational characteristics and the reliability of onboard systems. Work under the upgrade program on 47 bombers was completed in 1998, and upgrades on an additional 24 aircraft, if budgetary funds are allocated for this purpose, are planned to be carried out at the end of 1999. The cost to modernize one aircraft under this program in 1996 prices is $2,250,000. In 1993, the defensive 20mm Vulcan gun was removed from all B-52 aircraft that remained in service. The price of one aircraft was $8,700,000 at the 1962 exchange rate. From the end of the 1970s to the end of the 1980s, $5 billion were spent on modernizing B-52 aircraft. The average cost of one B-52 flight during the Vietnam War period was $41,421, according to a 1970 estimate. And at the end of the 1980s, it was $37,170. Taking into account an average cost of one flight hour of $5,900 and an average training flight duration of 6.3 hours. The average maintenance labor intensity for the B-52 in 1993 was 33 to 41 man-hours. The first batch of 47 bombers was modernized by the end of 1996. In addition, the military planned to modify another 19 aircraft. The modernization of one bomber cost $2,250,000. In the 21st century, Boeing proposed a much more extensive modernization of the aircraft's electronic equipment, using technologies from new civilian airliners. In particular, there were plans to install a powerful high-precision radar and color multifunction liquid crystal displays in the pilot's cockpit. The aircraft were to receive a real-time target guidance system. It was also planned to modernize the underwing pylons for cruise missiles so that conventional bombs could be carried on them. But all these additional works depended on how much money was allocated for defense. The United States Congress decided that 66 bombers would remain in service with the U.S. Air Force until 2030. To make the aircraft more reliable and reduce maintenance costs, Boeing, together with its partners Rolls-Royce, Allison, and the airline American Airlines, proposed to the Air Force leadership a plan to re-equip the bombers with 4 Rolls-Royce engines. According to the agreement, Rolls-Royce would lease these engines to American customers and service them for a fixed price per flight hour. The new idea was to include the U.S. Air Force in this program. During July and August of 1996, Air Force representatives analyzed this proposal from an economic standpoint and decided to begin research and development work under this program. They calculated the cost of maintenance and repair for the aircraft up to the year 2030. It turned out that the most expensive item was the old Pratt & Whitney engines. To reduce the cost of repairing these outdated and worn-out engines, the decision was made to replace them with more modern ones that offered better fuel efficiency and lower operating expenses. For a year, Boeing specialists studied various engine candidates. In the end, they chose the Rolls-Royce engine, which exceeded the combined power of the 2 older engines. The thrust of one new engine was 42,750 pounds, while a pair of old engines produced only 33,730 pounds. Thanks to the better efficiency of the new engines, the bomber's range without refueling would increase from 4,040 miles to 5,965 miles. Takeoff and landing distances would also be reduced. In addition to replacing the engines, Boeing developed a package of related upgrades. These included installing an auxiliary power unit that would allow the engines to be started without ground equipment. The cockpit instrumentation was also to be modernized with liquid crystal displays similar to those used in passenger airliners. The engine control levers would have to be updated as well, since the pilots would now be operating only 4 engines instead of 8. Furthermore, the aircraft would receive a new system that compensates for yaw in the event of an engine failure, as well as a new powerful generator similar to those used on large passenger airliners. The engines, pylons, and nacelles are identical to those used on civilian airliners. The engines would be shipped from England to the United States in disassembled form, then assembled and tested at a plant owned by American Airlines, the main and most experienced operator of this engine type. Maintenance during operation would also be carried out by the same airline using its service centers worldwide. The modernization of B-52H aircraft and installation of new engines would be performed by Boeing at its plant in Wichita, Kansas. The American side's share in this project amounts to 52%. Considering the future production of spare parts for the new engines in the United States, this share could increase to 79%. If the Air Force approves the proposal, the entire B-52H fleet would be modernized by the year 2005. The work carried out by Boeing was estimated at $1.3 billion, while Allison would receive $3 billion. The world's first jet-powered intercontinental bomber and one of the record holders for service longevity in its class, the B-52 will remain the main airborne carrier of the United States strategic nuclear weapons for the next 30 years. The aircraft is built according to a conventional aerodynamic configuration, featuring a swept, high-mounted wing with a large aspect ratio and a swept vertical tail assembly. Roll control is achieved through the use of spoilers. Because the wing of the airplane is very flexible, conventional ailerons at the wing tips would be ineffective across different flow regimes. Moreover, they could even act in the opposite sense. For that reason, small-span ailerons are used in combination with large interceptors located on the upper surface of the wing. The high-lift system also includes large Fowler flaps, which are extended to the maximum angle both during takeoff and during landing. 2 pilots, a navigator, an electronic warfare systems operator, a flight engineer, and a navigation systems operator are accommodated in a 2-level cockpit in the nose of the aircraft. A gunner on early variants of the airplane was located in a separate compartment in the tail. Now the entire crew is concentrated in the forward cockpit. All crew members have ejection seats. The landing gear is of the bicycle type, with 4 main 2-wheel struts and 2 auxiliary struts at the wingtips. During retraction, the wheels of the main struts rotate by 90 degrees. The right struts fold rearward, the left ones forward. All struts are hydraulically actuated. During landing, all wheels touch the runway simultaneously. When parked in hangars, the keel can fold to the right on a hinge assembly. The airplane is fitted with an in-flight refueling probe that uses a telescopic boom. The airplane is equipped with an electro-optical surveillance and navigation system that includes, installed in 2 rotating turrets under the nose, a television camera for low-light conditions, and a forward-looking thermal imaging system. They provide low-altitude piloting and assessment of attack results. The onboard electronic equipment suite includes a Doppler airspeed and drift meter, an inertial navigation system, a radio altimeter, a bombing navigation system with a digital computer, a modernized ground mapping radar station, and an obstacle avoidance radar. The B-52H bomber is fitted with a duplicated electronic warfare system. During modernization, the tail gun installation was replaced by a 3rd set of electronic warfare equipment. The aircraft employs a stability augmentation system that damps bending oscillations of the rear fuselage. It is one of the first such systems to replace previous methods of eliminating aeroelastic oscillations. Previously, it was necessary to reinforce the structure, use mass balance weights, and impose restrictions on allowable flight regimes, which made the airplane heavier and limited its capabilities. Weapons can be carried in the bomb bay, length 28 feet, width 6 feet, and on 2 pylons under the wings between the fuselage and the inboard engines. Strategic nuclear armament includes thermonuclear bombs of varying yields, from 1.45 kilotons to 2 megatons. By agreement between Russia and America, no more than 10 nuclear bombs should be carried on board a single aircraft. The B-52 bomber was originally designed for high-altitude flight, but later it came to be used very differently, at low altitudes where the air is rough and turbulent. This led to serious problems. Structural loads increased, the airplane wore out faster, and it became more difficult to control. How dangerous such flights could be was shown by a terrible accident near the Rocky Mountains in the state of Colorado. Turbulence created such strong loads on the vertical stabilizer that it simply tore off in flight. That catastrophe forced engineers to search urgently for a solution. The result was a special stabilization system that reduces peak loads, lessens structural wear, and improves controllability. The system works in a simple way. It monitors airspeed and acceleration and then automatically controls the rudder and elevator through powerful hydraulic actuators. Cruise missiles are another important element of armament. The aircraft can carry 10 strategic cruise missiles with a launch range of up to 1,550 miles or even 2,175 miles. That limitation is also set by international agreements, but technically, if necessary, each bomber, after additional equipment installation, can take up to 20 shorter-range missiles, 12 under the wing and 8 in the bay, or 16 longer-range missiles, 4 in the bay. All strategic cruise missiles are equipped with nuclear warheads with a yield of 200 kilotons. For strikes against especially important targets in conventional non-nuclear conflicts, the B-52 has tactical cruise missiles with a launch range of 745 miles. At the beginning of the 2000s, there were plans to arm the bombers with a new generation of low-observable tactical cruise missiles. Some aircraft can carry anti-ship Harpoon missiles, 8 on internal carriage, or 4 Raptor missiles under the wings. Arming with other types of guided missiles was also considered. In 2000, there were plans to begin equipping the bombers with new guided bombs with satellite guidance and glide bombs. Typical bomb armament includes freefall bombs weighing from 496 pounds to 2,006 pounds, cluster bombs, and naval mines of various types. A typical combat load is 24 bombs of 496 pounds each or 8 bombs of 2,006 pounds each in the bomb bay. Defensive armament was located in the tail turret. Previously, there were either 4 machine guns of 0.5 inches caliber with 600 rounds each, or 1 automatic cannon of 0.79 inches caliber with 1,200 rounds. But in 1993, a decision was made to remove the gunner from the crew complement, and subsequently the guns began to be removed from the aircraft altogether. The practice of flying B-52s with nuclear bombs on board made them a source of increased danger even in peacetime. Twice the world came very close to nuclear catastrophe. In 1961, a B-52 carrying 2 nuclear bombs crashed near the town of Goldsboro in the United States. And in 1966, another aircraft with 4 atomic bombs crashed into the sea after a mid-air collision with a tanker near the Spanish town of Palomares. The bombs had to be raised from the seabed after a prolonged, complex, and extremely costly salvage operation using deep-sea apparatus.